I just wanted to just let everybody know that we really want this to be interactive, although I'm presenting at the moment and we'll have different presenters at different times during different meetups. I don't want to hold the mic. So if you find something that, correlates to what you're working on, or you've got some really great insights that you've learned on a project you just finished, we're all for that. We are into learning rapidly, kind of that fail fast model. We're all trying to inform ourselves. And if we can connect each other to subject matter experts, that's what we constantly do. So one really cool thing about this community is that we're very open to working together, to collaborating, to providing insight to one another. So there are very few kind of tech secrets or anything like that. We don't really have time for it. So what we'll be talking about today is the cutting edge of AR and VR research. This is by no means an exhaustive list. I'm kind of giving you the 20,000 foot view. A lot of you already work in this space. Some of you run these labs. I'm just going to let you know kind of what I was looking at, things that are intriguing, things that might be influencing the work that you do. And then the idea is, this is kind of like the state of meeting. We usually have one at the beginning of the year, and it influences the meetups that we have over the rest of the years. So if you guys are interested in doing a deeper dive on any of these things, just let us know, and we'll get somebody that works at one of these labs to run one of the meetups. And that's how we typically schedule out our meetups for the year. So, like I said, this is a non-exhaustive list. Some of the things that we'll be going over is AR and VR for the elderly, immersive education and what that may mean, the use of sensors to create photoreal simulations, the capturing of the real, developing tactile solutions to create better immersion or more robust interfaces, the future of work, tools to rapidly populate a 3D world, and a little more on robust interfaces. I'll have some examples and stuff like this. We'll take some time to either watch some videos or show you some slides. This is an open conversation, like I said, so if something wows you or like I said, matches up with work that you're doing, please speak up. But first, something happy, right? Like, it's been a tough year. Things are still kind of going on. I wanted to present something that I found pretty intriguing, which was, there's a study recently published in Korea through the Taipei Medical University. And the title of the study, and this slide will be available for all of you if you need this info, is called The Effects of Virtual Reality Sessions on the Quality of Life, Happiness, and Functional Fitness Among Older People, a randomized control trial from Taiwan. I believe they had upwards of 300 participants in this particular trial. These were folks that were 80 years or older. Some of the inclusion criteria included being able to speak Mandarin Chinese, could give informed consent, no current history of serious medical disease, ability to perform activities of daily living, understanding the intent of the study, general, human trial stuff. But what was intriguing here is that the quality of life, as they assessed it, improved by some of these metrics, which were pain, discomfort, anxiety, and depression. Their statement after the study was completed was that happiness significantly improved in the intervention group relative to the control group. Among the functional fitness tests, the back scratch test first and second back scratch test were measured to be significantly improved in the intervention group in comparison to the control group. So this is a study being done at a medical university in Taiwan, just giving a little more efficacy data on the use of VR to managing pain and anxiety. I thought that was interesting. It's relatively new. I know people are often asking, hey, could VR be used in a medical setting? This is an interesting touch point for those of you that are collecting data about medical efficacy and quality of life. So I just wanted to share that. So
I actually have a quick question. Sorry.
Go ahead.
So with older generations, specifically the way that like their inner ear, I used to be a dancer, and so a lot of the stuff with like vertigo comes in from a lot of stuff with VR. Don't elderly people actually have a harder time in VR, specifically with the becoming sick, because their equilibrium isn't like the same as what as younger
Yeah,
kids are.
so that's an interesting point. Some of the instances of VR usage that I've seen are almost like telepresence, right? So they're much more static, right? It's about traversing an environment, not using your body, but like either with a teleport technique, or kind of a choose your own adventure button, like you hit a button. It's almost like Google Street View. So you're not actually forcing the user to kind of locomote around the room. Um, and so it'd be interesting to see in this study. I'm not 100% certain as to how they were implementing the VR itself, but the way I've seen it in retirement homes and some medical establishments has been a 3DOF headset, really being used to play back some static 360 environments, or 6DOF environments where you're really just teleporting around the room. That tends to battle that inner ear problem. So I would say that the presentation of the media goes a whole, a heck of a long way as to the participants' comfort level. Does that help?
Yes, thank you.
Yeah, sure. So I wanted to jump back a little bit of time and just, as we talk about immersive environments, I wanted to show you an example of something being used in some retirement homes. This isn't the only version of it, but it's an interesting use case that I think will present some novelties to some of you that may not be familiar with this type of presentation. So let me just hit play and show you what this thing is.
My name's Jim McLeod. I'm the Customer Relations Manager here at Scarlet House, part of Care UK, and we're delighted that we have the first REM Pods train feature in the UK in a care home. So when they first approached us and told us about the idea about the care home, the train feature, we just thought it was absolutely amazing, because one of the things about people who are living in a care home or living with dementia is to be able to reminisce. It's a great part of the activities that we do. So the train feature is brilliant because it actually gives them the opportunity of reliving memories, reliving family holidays. And it's not just a residence experience, it's a relatives experience as well. So we invite relatives to come along, have afternoon tea with the residents, and just enjoy that opportunity to reminisce on times gone by. So since we installed it a couple of weeks ago, we're using it every day, and the amount of interest that we get from residents is absolutely fantastic, to the extent that they're coming back and asking, can we go on the train again? So the feature itself has proved not just to be a hit as a one-off for the residents, but they're enjoying it as a daily part of the activities that we have here at Scarlet House.
So pretty interesting stuff. If you can imagine that, the extension of that experience into augmented reality or virtual reality environments, the possibilities start to open up for care of the elderly and different novel uses of the tech, really to instigate conversation or community. And I wanted to show you that it's an old example. It's probably from like 2016, 2017, but a ton of retirement homes are starting to institute kind of immersive, engaging experiences that look a lot like that train experience. That train one seems to be kind of like a basic building block that is informing these institutions of the types of rooms that they could be creating for the elderly. So some key takeaways from those two examples. Virtual reality is one of the emerging technologies with a potential to improve well-being, quality of life, and fitness, right? So we're getting enough studies at this point to show that, yes, there is some improvement here and it's measurable. Older adults showed significant improvement in quality of life, happiness, and some functional fitness components among those who experienced virtual reality sessions. So between the two groups, separating the two groups, you've actually seen the needle move a bit in those areas when using these emerging tech. The research supports future considerations to use specific VR apps to assist active aging. So that's kind of interesting. So what are things that you can implement to have people be more mobile, or to be more conversational, or more community engaged? So I just wanted to provide some of those examples. I thought they were interesting, not necessarily the cutting edge, but certainly incredibly useful use cases for the tech. So schools are changing. This is, not a surprise to anybody who's, been awake for the last 18 months. Schools have had to rapidly shift from their current positions from their previous positions to the current positions of uh, telepresence and online learning. I got to go through this experience at ASU. So Arizona State University is like 2 blocks away from my house, and I get invited to go do stuff over there. And I'm also adjunct faculty teaching a class on immersive technologies. So this thing was interesting. It was called Dreamscape, I believe, and it was a motion platform-based immersive environment, full six off immersion. And so for those of you not familiar, 6 degrees of freedom basically means you're able to move around in the thing, right? You've got full agency in that environment. And so what it was felt a lot like kind of like a Disney or Universal Studios ride. You walk into this room, you put the headset on, you put a backpack with the computer on. Um, you've got I can't remember if it was gloves or if it was controllers. I think it was controllers, and you walk into a platform and you're basically flown to this other planet and shown all these different experiences that can happen, right? Doing biology in this immersive environment. Don, so you can provide some background on this. Looks like you've had some interactions with the system.
Yeah. So yeah, everything you said was right. The hand tracking is actually kind of similar to Vive trackers that you put on your hand, but they also have feet trackers, and it's like a 15-foot by 15-foot pod, they call it, but it's just like this room with railings that acts as your play space. And they also have the quote unquote 4D stuff. So there's things in the experience that you can reach out and touch, and they have props and stuff in the room that correspond to those things to add that level of immersion. And they also have sort of like wind effects and water effects that are included in these experiences too.
So as you can imagine, the level of immersion is very, very high. The level of agency is kind of a mix. There's like some on-rail stuff as well as some kind of personally driven exploration opportunities. I've heard good things and bad things about this system. Some complaints are that the university kind of teamed up with an entertainment company, and so there's a big question there: is like, should the university be building this on their own? And do we leave this up to entertainment companies to work with educational institutions? And it brings up a bunch of different kinds of questions. I don't mind instigating that conversation because I think it's a good question to ask. Do we want video game companies teaching our kids? Yes, no, maybe so.
So I wasn't expecting to speak, but
Yeah.
I'm Waft, and I'm part of this Dreamscape at ASU effort as well. I'd be happy to engage in that sort of conversation, but one of the big things is that we want to actually be using this pod to educate our students in-house at ASU so they can think in what Don was saying is the 4D kind of ways of thinking of these different haptic kind of interactions, this theme park style, like you alluded to, type of way of thinking. But we want to teach classes around this, and we want to open this up across the university to have lots of people participating and building. So that is our intent.
Awesome, thank you, Robert, and thanks for joining us. Robert has his own lab, which is actually mentioned in the presentation. So I just some key takeaways here. We will be challenged by how education looks in an immersive reality, right? It's not going to look like desks and a chalkboard at all. I mean, this thing has, flowers and plants and animals that you can observe, and you have a type of interface that allows you to do all kinds of interactive things. You're basically flying to another planet to do some research. Really interesting, but it will challenge the way that current curricula is developed. Educational environments will permeate our homes. So, right, like, what's the need if I could do some kind of telepresence setup, right? If I had an Oculus Quest, let's say, and there was access to that server back at ASU, I could do it from the house. I could literally do it from the house. And there's no question in my mind that those realities are going to start to extend into the real world with AR tech. So as that starts to become more pervasive, those environments will be able to pull in. You want to look at a dinosaur in your room, why not? It would make more sense to be able to pay the university and have access to that curricula than it would to not have it at all.
I have a question.
Yeah.
With children that have ADHD or ADD, do you think that it would be beneficial to them to use VR?
So that's a good question. I would be looking, since that's not my specialty, I'd be looking for efficacy studies around that particular use case. I don't know any right off the top of my head, but I would imagine that there's already some study in that space, and I'd be looking for something like Immersive Technologies with ADHD, participants or something to that effect. So sorry, I can't give you like a complete answer there, but it's not my area of expertise is all.
Thank you.
Yeah, you're welcome. So now for something a bit more hands-on. Let's talk about some of this research. I'm going to hit play here. This takes about a minute, and I'll chat a little bit about it. So this is out of Facebook Labs. This is some of the most recent research they've been doing around hand tracking. What's interesting here is that what you're seeing is actually a 3D model overlaid airtight on a recording of a person's hands. And what's crazy here is that they're actually capturing where there's occlusion, and that's been a considerable problem in the past. And all occlusion means is that when an object occludes another, it prohibits you from seeing the object in the background. Well, in this case, they've modeled the hand, and they can do some analysis around the motion of the hand. What does a hand normally do? How can it move? And they can assume the shape of the hand behind the occlusion. And so it's really interesting here. So here's what they wrote. The use of our hands illustrates the importance of tracking hands through self-contact and occlusion for many applications in computer vision and graphics. But existing methods for tracking hands and faces are not designed to treat extreme amounts of self-contact and self-occlusion exhibited by common hand gestures. And as you saw, like they're trying to intertwine these fingers and track what these fingers are doing. In traditional systems and systems that have existed prior to this type of research, the occlusion basically just makes that finger disappear. So what they're doing instead is they're trying to figure out, hey, what are the positions that finger could be in, and how does it get distorted when these two things intersect? And it's trying to model that. So right now, what you saw is a multi-camera, multi-angle setup. It's not currently viable as a single headset. I think they have something like 190 cameras or something like that, and then they set it up to process that data afterward. So it's not a thing that's going to appear in a headset like tomorrow, but it is the cutting edge of hand tracking, more or less. I mean, there are different techniques to do this, but this is one of the more progressive techniques. So the key takeaway from that is that by constraining a vision-based tracking algorithm with a physically based deformable model, Facebook Labs obtain an algorithm that is robust to the ubiquitous self-interactions and massive self-occlusions exhibited by hand gestures. Complicated way of saying, hey, we figured out some math that can actually track these deformable objects that traditionally wouldn't be tracked. Allowing Facebook Labs to track two hand interactions in some of the most difficult possible configurations of a human hand. Why would you need to do that? Well, possibly because new interfaces are going to come that require hand movement. So let's shift a little bit and talk about volumetric capture, not just the hands, but what about the entire body? What does that look like, and what could you do with that type of data? So here's a little Sony clip that they released recently. Volumetric capture has been around for several years now, but this is a more recent video released by Sony.
18年ぐらいダブルダッチやってるんですけど、実際に作っていただいた映像を見て、今まで知ってたダブルダッチとは違ってめちゃめちゃかっこよくってすごく感動しました。ロープの中の視点とかって見れないんですよ。カメラマンが入ってこれないんで、 当たっちゃうんで、360度もう上も下も全部見られるっていうところもあったのでワクワクしてます。一緒にやらせていただいた時にもう未来が来ましたねって言いましたもん僕。
空間そのものをどこかに伝送したいっていう気持ちがありまして、それを技術的に再現するためにはどうしたらいいのかっていうところから始まりました。
対象の人の周りにたくさんのカメラを置きましてキャプチャーします。でそのキャプチャーしたデータを使いまして3次元の 3D データというものを作り出します。カメラが本来はないような地面より下のアングルであったりですとか、外で置けないようなはるか上の方空にカメラを置いたりですとか、そういったことができるようになります。
ソニーの GS10 の強みはですね、カメラの映像をそのまま使うところにあります。お肌の質感だったり髪の毛のふわっとした感じ、お洋服の雰囲気などをリアルに再現できるところがポイントです。
一番苦労したところがそのクリエイターさんにちゃんと使ってもらうようにするっていうところでした。通常使っているワークフローの中にちゃんとはまるようにうまく加工してはめてあげたことによって映像制作でたくさん使ってもらえるようになりました。
GS10 映像を使って今までできなかった映像表現をクリエイターさんに楽しんでいただくっていうところがメインかなと思っています。一つのツールとして使っていただきたいなというのが我々の思いです。
2019年の春にライブで使ってもらうことができました。スクリーンにバーンって我々の映像が出た時に映像を見てお客さんが盛り上がってるのを見てやっぱすごい感動して本当にいいものを作れたなというふうに感じました。
これからはですね、その場で撮影したコンテンツをその場のお客様に届けて、例えばスマートフォンを使って自由な視点で見るっていうようなことができるようになっていくと面白いかなと思っております。
クリエイターさんと話していると視点が広がるというか、そういったところがあるので新しいその使い方みたいなのを一緒に作っていきたいなと思ってますし、我々は技術を上げていってで向こうはより新しい見せ方みたいなお互いにうまくコラボレーションみたいなことも今後できていければなと思ってます。
So super interesting stuff. Not particularly new. I think the new stuff is kind of baked in there. People have been doing volumetric capture for several years, like I said, and it's been cost prohibitive in the past. I visited a facility a few years ago, monster facility, just it was like the size of a stadium almost, it was huge. But it cost $100,000 per minute to capture, which is not going to work on a $2 or $3 million commercial budget. You're going to blow the whole budget just on a few minutes of footage. There's some folks out of Austin that are really interesting that have that price down to about $5K a minute. Which is a bit more manageable, and there are a lot of kind of mom and pop shops, like small labs and small businesses throughout the United States that are tackling this problem. There's also some really interesting work being done in New Zealand around the retexturing of volumetric recordings, and so all of these things. All I'm saying is that they're all kind of still in bloom. I'm happy to provide some insight if you all are thinking about capturing volumetric video. So something that was interesting about that was not old stuff is Sony specifically talking about the output of a volumetric capture fitting into some part of an existing workflow. In the past, really in the last let's say 2016, 2017, when it was kind of brand spanking new type of stuff, you were getting raw data that was like point cloud data, or you might get some geometry for you 3D modelers, but it wasn't very clean or had to be post-processed. And there was a ton of work that needed to be done to make any of this stuff fit within an existing 3D workflow. What Sony is looking at now is what format can they put it in where it's a drag and drop into Blender, it's a drag and drop into Maya, or it goes into an After Effects file, that kind of thing. And I think that standardization is going to tremendously help creatives that are really, they're not trying to be techies about it. They're really just trying to, hey, I recorded a 3-dimensional recording. I want to cut it up, or I want to do some really cool stylization to it. And I don't want to spend a week doing that. And I don't want to spend $100,000 per minute capturing it. So that's really interesting. Volumetric video will have many applications in XR. from performance capture to scientific analysis and training. So you can imagine capturing an entire scenario, a few versions of that scenario in volumetric video, and then actually having an opportunity to walk through that environment and seeing it play back in different ways, right, as a bystander or as a participant in some kind of training. The tech is still prohibitively expensive, like I said, for small businesses at $5K a minute. That's still pretty pricey. However, large organizations are already testing the waters. Not mega companies, but companies that make a few $1 million a year are starting to look at this as an opportunity to either enhance training or data visualization. Just the ability to have that data is useful for them.
So I had a question about like, where's that money going to? Is it going to processing expenses or like the people actually editing?
Yeah, so that's a good question. Some of it is power, some of it, so the facility that I went to that was charging so much, it had several petabytes of storage all on fiber optic. So it was the sophistication of their setup. It was being able to crunch that data, store it relatively quickly. Like they could do a full volumetric capture with some real-time manipulation after about, I want to say it was like 45 seconds of processing. So the ability to be able to get it back so fast was part of what made them expensive. On the other hand, like the mom and pop shops have to pay for the computational power and the rigs, and they're constantly updating the camera rigs on these things to get higher and higher fidelity of capture. So I would say that it's either going toward the development of the setup or it's going toward processing afterward of the data.
Gotcha. Thank you.
Yeah, no problem. Okay, so speaking of hands-on, to return back to hands-on, it's unfortunate Robert left because his group is doing this stuff. Maybe Dawn, you might be able to talk to some of this stuff. I'll do the best that I can. This is pretty cool. This thing is called Swish.
Swish provides physical sensations of fluid in virtual vessels in virtual and augmented reality. To do this, Swish tracks the position of fluid particles in the virtual software environment. As the user manipulates the vessel, the virtual fluid moves around. We map the center of mass of the particles to a cylindrical coordinate system and use it to actuate motor movement to physically match the vessel's center of gravity in real time. This provides the sensation of sloshing liquid inside of the vessel. Swish provides physical.
So pretty interesting stuff. The idea there is, okay, so you've got some type of fluid, right? And in VR, and which is interesting already, some kind of fluid dynamic simulation, but you're not able to feel it. And so Swish, what they're doing is they're actually putting a type of motor inside of this object. And so when you touch the object, you're getting the tactility of touching the object, you're seeing it in virtual space, and then you are swishing literally the volume of liquid that's inside and actually feeling it in addition to seeing it. So if you can imagine being in a VR headset, you might see a container, a glass container of liquid, right? A clear glass container. But in the real world, you're seeing this 3D printed bucket with the motor inside. So when you're in the headset, you're seeing this clear container of liquid, you're sloshing it around, and it's feeling the way it should feel in real life due to the mechanics that are happening inside of it. So the chief mechanism behind Swish is in the use of virtual reality tracking and motor actuation to actively relocate the center of gravity of a handheld vessel, emulating the moving center of gravity of a handheld vessel that contains fluid. So all it's doing is it's using that motor to simulate the liquid in its position inside of the object. In addition to solving challenges related to reliable and efficient motor actuation, the lab's Swish designs place an emphasis on reproducibility, scalability, and availability for the maker culture. To that end, they plan to broadly release their schematics. I'd love to see what that would look like made into an open source project and provided to schools that may have some headsets.
Hey, and I want to mention that this is Bill Maher here. I want to mention that I was building something similar to this, but I had inside it had a gyroscopes too, so I can actually spin it by changing the frequency. I mean the rotation of the gyroscope, so I can actually change its inertia.
Awesome.
So I'm just wondering if you guys in Swish team, have you tried adding gyroscopes to this stuff?
Are there any folks from the Swish team on? I think we might have lost Robert. I don't know if Don.
Okay.
I don't know if Don can speak to it. Don, do you know anything about that?
No, I wasn't a part of this project, but I am linking a paper about published by this lab if you're interested in reading it.
Awesome. Thanks so much. And thanks, Bill. Yeah, definitely. Anything that can improve on these types of technologies. This is why I'm hoping that this thing goes open source so that we can start messing with it. That would be an awesome meetup to, bring this stuff together and do some kind of testing around it.
Oh, I'll definitely make one then. If it's open source, I'll go throw one together, or a bunch of them actually, right? So okay.
Yeah,
cool.
Very, very cool. Let me find out where that stuff may be kept. Hopefully, I'm not sure if they're done with it yet, but the idea here is that it looks like they want to release the schematics out. So new affordances. Now, as we started to kind of stack tech on top of this stuff, you start to see that the interface modalities start to drastically change, right? Like suddenly we're using our hands to do things that doesn't quite look like drag and drop anymore. There's like actual volumetric interfaces, three-dimensional interfaces. So this is Shelley Peterson. She works at Lockheed Martin Space. They've been implementing this system that she's going to talk about since about 2017. It's for the development of the Orion spacecraft, and I believe they're using HoloLens to do the development of the Orion spacecraft. So she's going to talk a little bit about that and then discuss the affordances that are possible due to the use of AR.
How are we using AR in these environments, in the production environments for Orion? These activities started back in 2017. You may have seen some of this information in the past. We used augmented reality in the early stages for drilling and for torque applications, and we saw about a 35 to 50% touch labor reduction. Now, our goal was to reduce what we call information overhead, which is the time to get to the activity. And in those cases, you can calculate it at about 98% touch labor reduction. But if you look across the entire activity, it's about a 35 to 50%. Now, in addition to that, for training, we were taking 8-hour activities and completing them in about 45 minutes. That's about an 85% reduction. Now we're looking at activities where the question for some activities is whether training is needed at all. We're starting to use terms like training-free activities. Training-free, I think, could be very influential in the very near future. For torque applications, now I'm a mathematician, and I know that some of you are already looking at this, saying there's a 50% touch labor reduction, but a 6-week activity is completed in 2 weeks. That's not a mistake. Our technicians were having so much fun, they worked a little bit longer days, and they, on their own choice, and completed the activity in 2 weeks. We're starting to put numbers on what you would call fun. How do you quantify what happens when technicians have fun or enjoy their work, or enjoy their work more in this case. And then there's also the non-step-based instruction, which we often think of work instruction as being step 1, step 2, step 3. We have many activities that do not fall into that category, and so we experimented with ways to represent the data differently so that you could have highlight or spheres that are highlighted and labeled that you would select, where you can navigate more easily to the information layer that you need in order to do your work. With that activity, we reduced 1,600 hour activity down to about 1,000 hours, which is about a 37% reduction in touch labor. But even with these activities, we were looking at ways to incorporate all different types of bleeding edge technologies to advance the state of AR for our production teams. But we also knew that we needed to pay attention to where we can see the value even beyond what you see here. And I felt like we were missing some things. I felt like we were not paying enough attention to what we consider as the simpler use cases. They may not be as attractive at the start, but I'll show you a few of these. This is a spacecraft adapter jettison panel. You see the people standing at the bottom left corner as a reference. It's about a 15 by 17 foot panel that's curved. There were some challenges with this activity. The task is simply to mark the locations where these click bonds, which are fasteners for cable harnessing, where they would be placed. And on the right side, you see the technician with a stencil, and he's just drawing the location. Normally, it would take several days. They completed this task in about 2 hours, and I'll show you more of the details on that in a moment. But in this environment, we often think that the models will represent exactly what you see in the environment. In this case, that panel is flexible. And so it's more curved at the top in this case than it is at the bottom because it's the support arms. So when you're trying to overlay a model onto the structure that's not sitting in the same geometry as it does in the model format, it can be a challenge. I very quickly went back to the drawing board right there in the room and started thinking about ways to solve it.
Okay, so a lot of ideas there, right? Some of what she's saying is, hey, some of the affordances you'll find aren't in the sexiest of places, right? Like just figuring out how a harness is going to be hooked up to an interior panel may not sound very awesome, but reducing the time from 8 hours to 2 hours to do it when you're using AR, that definitely should sound awesome to that particular worker, right? Because now you're not spending that extra 6 hours that day. You can actually knock out a few. The other thing is that she's saying that, so this is a potential problem, some fit checking issues. So the curvature of the metal is malleable. So you bring in an AR model of a thing that's supposed to have a certain shape, but for whatever reason that day, that production model is slightly different than the one that you're trying to fit check against. Well, that brings up all kinds of problems. Hey, I'm trying to reference a shape that doesn't exist in front of me. There's this other shape. And how do you resolve that? So that's a potential problem of the future, which is I'm looking at some version of this. We do similar type of work at my company. And, you know, I was talking to a friend who does some stuff with the Marines. And he was saying that they were looking at they were using the HoloLens to do some stuff with, I think with Humvees. And they wanted to like change a tire or something, right? But they found that when you put the human in the loop and there's an emergency of some kind, or, you know, whatever, the limited tool set, they'll actually change what the ground truth data is. The ground truth being the actual Humvee, not the 3D representation of the Humvee. And we have to be aware as developers in this space that that perfect representation in the 3D model may be only part of the story. That tire could have already been changed, the bolts changed, they didn't have sufficient number of bolts, they used a shoe to wedge in a space, they had a spare piece of metal, whatever it might have been. you're now looking at two different things, and the ground truth has changed. I wanted to bring that up because I think we tend to talk idealistically of like digital clones. Once you scan it once, right, like you're good to go. But no, there may be a need for ubiquitous scanning, or there may be some type of machine learning that's necessary to do better fit checking on the spot. So Lockheed is looking at that space for the development of their spacecraft. Some key takeaways: there's no single function of AR in manufacturing. She's already telling you, hey, just in the few, at that point, in the few months that they'd been into it, a couple of years been into it, they were already starting to find different types of affordances, not just one use case, but several different types of use cases. The fact that she is skipping just-in-time training to go to no training whatsoever. Like, imagine walking into a space where I imagine myself, I've never welded anything, and being able to use a device and welding two pieces of whatever together because the headset says that these are steps to do it, and accomplishing that task. She's saying that they're finding that as being one of the affordances that wasn't entirely expected before. And that's pretty amazing. Now, whether those folks are learning that task, that's another question. I'd like to see the data on that. Is it educational, or is the machine basically driving the person? Yeah, great question, Laurie. I think what she's getting at with training free, and I'll put the link to the entire video there, is really no prior experience whatsoever. So you've got no training time ahead of the time that you're in that room, and you know how to do it because you've got some kind of AR interface for it. Massive affordances are possible when XR is used appropriately. Again, it's going to take kind of some adjustments to figure out what the appropriate use cases are, some efficacy studies like the ones I was describing at the beginning. Yeah, Lori, I think what she's saying is no prior training. Really, just do a thing. Like, you haven't been informed on how to do it prior to stepping into the room, but the headset's giving you, I guess, just-in-time training. It's something kind of like that. Training free activities could be influential to the American economy, right? So we have a huge gap with trades workers and subject matter experts, and it's part of what is hurting our advanced manufacturing sector in the United States. So training free activities, I imagine being able to augment someone who is high school graduate or lower, right? Maybe even less education. I don't know if we could pull it off with folks that can't even read, right? Like, are there interfaces that are possible to get those folks able to do some pretty technically difficult things? I think the answer is yes. I think it's going to take noodling through how to provide that data to them, how to provide that instruction to them. And then fun. I was not expecting that from Lockheed. Fun can be used to enhance work. My suspicion is that the novelty of the headset, suddenly having this tech where you can see things that nobody else can see, was bringing some of these workers to stay longer, maybe at work. Like, oh man, if I crank this out, I will have finished the sucker in like 2 weeks instead of 8 weeks or 6 weeks. I don't know how long that'll last. I'd like to see some long-term data whether fun is still something they can attribute to the affordances they're finding. All right, so let's put our whole body into it. This is not super new, but really interesting because we started talking about fit checking there and like real-time fit checking. What if the shape is deformable? How do you deal with that in AR? This is an interesting study on AR costumes that was done by Disney. So let's see. This is an example near real time. So person poses, they capture the pose, boom, there is a 3D model wrapped around them. They described it as an airtight 3D model. So totally conforming to their body shape. With and without hands, the costume with and without hands. This starts to answer that deformation problem, right? Just kind of interesting. If that's a shape that's not a human, could you then deform your ground truth data to the thing that's actually now new ground truth? I mean, there's a lot of technical implications to being able to do real-time or near real-time fit checking using an RGB sensor. And that's what Disney is doing here. This is, it's called AR costumes, automatically augmenting watertight costumes from a single RGB image. So in layman's terms, can I take a photograph of something with a regular camera and create a model around another object? So Disney research described a method to automatically augment a watertight digital costume onto a person's body from a monocular RGB image. When overlaying the digital costume onto a body using pose matching, several parts of the person's clothes or skin remain visible due to differences in shape and proportions. In this paper, they represent a practical solution to the artifacts which requires minimal costume manipulation and a straightforward in-painting approach. To their knowledge, their approach is the first to deliver plausible watertight costumes from RGB imagery only and is compatible with mobile devices. So that's pretty interesting stuff, right? We're not using LiDAR, we're not using volumetric scanning, we're getting rid of all that stuff and saying, what can we actually pull off with a single image? So now, if you go back to Shelley's problem and the Orion capsule, could a single photograph help inform the AR system so that those positions now conform to this new distorted shape? That's where airtight fitting and fit checking can be super, super useful. You can start doing all kinds of stuff. Not to mention the fact that, well, now could you figure out exactly how much cloth you would need to wrap somebody, right? You could have things built to custom size. And it's not just clothes. Could you do that to other objects that require some kind of exterior, some exterior wrapping of some kind? It's really interesting. That stood out. It wasn't kind of a common thing. I hadn't seen a lot of that. And Disney's been doing a lot of research in this space around AR for entertainment that may be applicable in other areas. So in this case, several methodologies are employed, right? Pose detection, proportion checking, in painting. They do some really cool stuff. In painting is this method by which you are kind of making up for null data. So like, imagine you have a really janky photo, right? That's all kind of messed up and it's got these scratches. Well, you could go by hand, and this is what people have done in the past, right? And restore it by hand by making up some of that information. In painting is the digital process of doing that. And so there's now some machine learning software that will allow you, to kind of guess, have the machine guess what fits in that space. And that is, orders of magnitude faster than a human being doing it. So there we've got some machine learning with pose detection, which is, some algorithmic inverse kinematic stuff. Proportion checking is another algorithm. And then, like I said, real world fit checking could be used in several industries. It doesn't have to just be entertainment. It's interesting that they've been able to do that, but you could do all kinds of cool stuff around tubes or complex shapes that need some kind of wrapping. The super, super interesting thing here is that this solution is a mobile sensor friendly solution. So now you don't need a huge apparatus or some complex LiDAR detection system to some LiDAR system to detect the shape of something. We can do it with a photograph. I wonder what level of accuracy you could achieve with multiple photographs, or if that's even useful to them. So let's just talk about toying around for a little while. We started talking about how these interface modalities may change. So this was kind of novel, like something kind of interesting here. We know what up, down, down, left, right looks like on a joystick. What does the manipulation of a volumetric thing, a character, a shape, whatever, in a 3D world look like? Does that look like a joystick still? So here's some interesting research also out of Disney around the manipulation of a puppet in three-dimensional space. So he's grabbing the puppet. And they basically start to add some advanced 3D animation to this interaction. right? Where's the joystick? Where are the buttons? Like, imagine showing this to somebody 15 years ago. Really interesting. And like I said, a novel approach to that interface design, right? There are very few cues that we're familiar with at all. It's all touch-based, and it's really, in many ways, being controlled by the camera, like the camera. And the camera, of course, is probably doing some SLAM-based stuff there, just kind of getting some geometry, figuring out what the geometry of the table is. I think that's why he was looking around with the camera at first, just to make sure that he knew what this object was being bound to. And then where are the buttons? The buttons don't look like buttons anymore. Right, accelerometer, of course. Yeah, exactly. So the accelerometer is playing some function there in the manipulation of this puppet. This gets really interesting for those of us that are kind of into UX UI. It starts to challenge what we're familiar with. It like really kind of changes the previous paradigm of 2D interfaces. And I'll keep talking about that. So this is called Puppet Phone. This particular test was called Puppet Phone. The virtual character moves in order to follow the user gestures as if it were attached to the phone via a rigid stick. This yields a natural interaction similar to moving a physical toy, and the puppet now feels alive because its movements are augmented with compelling animation. So using the smartphone, their method ties together the control of the character and camera into a single interaction mechanism. That's the new part for UX folks. They validate their system by presenting an application in augmented reality. So they had some tests, and they basically compiled them all into this particular showcase, this tech demo, to show whether those tests would work. And it looks like it does. At least it's a novel interaction. So key takeaways from this one. So new interface modalities will be necessary to manipulate objects in 3D space. Yes, we will be able to have 2D interfaces floating in 3-dimensional space, but where's the fun in that, right? Like if we're talking about like a desktop, right? The desktop of a computer, this is like a 40-year-old paradigm. I don't want to drop a virtual file into a virtual folder. I want to pull out a virtual cabinet and do cool stuff with it, right? Like the idea of AR and VR giving us Z-axis is what's really important there. What could you do with volumetric or spatial information that you couldn't do before? It's certainly interesting. Like I think of the Iron Man headset. There's a lot of 2D going on there as opposed to 3D. But it'd be really interesting to see that headset kind of work maybe more the way his AR does in his lab, which is like being able to grab things, being able to, reach into objects and interface with them in that way. Whether it's with puppets or with, some kind of complex genome encoding. So the last one is kind of a big one, or the last two. So as during Web 2.0, interfaces will drastically change. So those of us that saw the shift from kind of initial web to this, more responsive web, there are things that we kind of take for granted now. Sliding from the side, sliding from the bottom. Those are not modalities that were comfortable. Like it used to be that you had to see the button, that you had to see the interface. Could it be that there is a type of interface that's almost completely invisible? Challenging stuff. And then the last thing is, if it becomes that easy to control these synthetic characters in a real world environment, you can kind of start to guess when digital toys start to show up, right? Like digital characters will permeate our world, for better or for worse. I think we're going to end up in a place where you could have basically an unlimited amount of toys that don't take up any space that somehow interact with the world that you live in. That's an interesting thought.
I have a question. This is something I've been playing around with a lot recently, which is to use the cameras, camera on the cell phone, and then be able to use that as a sensor. So one example would be to actually have how the old style puppet where you have all these strings that you're attached to. Well, my camera just looks at a little ball that's on each of the strings, and then the camera will figure out how long the string was, and then based on that, do the reverse kinematics and actually, model where the puppet is actually positioned. Mm-hmm, mm-hmm. So the big idea here is you can use all these cheap cameras and have them positioned around so you could actually use the camera as an input. Like for instance, I did that with the wheelchair. I have a camera looking at the guy's what do you call it, the little toggle switch on the wheelchair, and I just take a video of that, and then from the video I see where the position of the joystick is, and then I would use that to generate the input.
Interesting.
So I don't need to physically hook this stuff up. I can just have a camera looking at it and see these. So now the cameras are so cheap, it's pretty easy to actually, look at a video and figure out where the position of the stuff is.
Yeah,
I don't know if a lot of people do that, but I don't know.
It almost feels like a state machine, right? So like, it's like if I can regurgitate that back, right? If I had a control panel for an arcade machine and I had a VR headset on, and your control panel had a camera pointing at the buttons, well, I guess just hitting the buttons themselves, you could get that sensor data. But I get what you're saying, that you could do it all with camera. Yeah, you could do it and have some kind of solution that way. It's interesting for analog interfaces. I think the first one that you were talking about, which was like the puppet itself, it's interesting for systems that may be all analog and not currently digital. And is there a way to transfer via camera from an analog interface out to digital? Like, could somebody, here might be a version of it, someone that is a master puppeteer, that data then driving a digital representation of something somewhere else just based on camera data.
Oh yeah, and if you watch a master puppeteer, and there's actually one in Phoenix, by the way, called, I forgot what it was now, but it's over downtown, and you'll never be as good as mechanically you'll never look like a master puppeteer. So the best I can do is take a look at the video, look at the position, and come somewhat close to it.
Yeah, I'm thinking about weaving now, right? Like what are places where people are building things with their hands that are not digital processes, where you could actually telerobotically operate something else somewhere else? That's interesting.
Yeah, so I don't know if there's much research in that, but it's easy for me because having a camera is much easier than having all these crazy sensors and wires going everywhere. So anyway.
Are we talking something similar to the goldfish playing, I think it was Pokemon specifically, where like you took you took a camera and then you took the goldfish bowl and split it into 4 different sections. Actually, I think it was 8 different sections, but where you had A, B, up, down, left, right, and then your trigger buttons.
Got it. So the goldfish is like playing Pokemon?
Exactly. So just throughout the day, and I think it came from specifically the Twitch stream in which they streamed the ability to play Pokemon through the Twitch section.
That's it. That's super cool.
Cool.
And it became.
And so they used this goldfish, just put a camera to it with a backing, and then throughout its day, it would swim up and go forward. And it's quite interesting.
That's cool. Yeah, I can imagine, even a person driving some kind of, I don't know, data visualization or something, some kind of mechanism moving in through it. So it's kind of scary to think about, but also super interesting. Like, if our apartment or our house is the fishbowl, what could you be driving by walking around the fishbowl, right? Like, I start to think about those retirement homes. Is there a game that can be played that has people doing different activities in augmented reality space that produces output somewhere else?
Well, the gadget that I put together with this camera was to have somebody in a wheelchair, as long as they can move the joystick, and it would be input to Google Maps, so they can actually drive around in Google Maps sitting in their wheelchair and still be able to go around, and they'd be basically driving around in Google Maps.
Very cool.
So
Very cool.
Okay, but I guess do a lot of people do that? But I thought it was kind of neat, but I don't know. Maybe
I don't know, but that's super interesting. Thanks, Bill, for bringing that
Okay.
up. That is super, super interesting. Accessibility. Okay, so next one. So since we're talking about puppets, because puppets leads to more conversation about puppets, let's talk a little bit about Unity and a presentation they gave at Unite Berlin a couple of years ago. This is still super useful stuff because I don't think a ton of people are doing this, But those who know, this is just a great type of magic trick.
Here's a new workflow for facial animation that takes a fraction of the time. Let's say I want to animate this character here. This beautiful character. I have an iPhone 10 right here. And if I look into the depth camera, you'll see the mesh on my face, which is working with all 52 blend shapes to match my expression to the expression of this character. Let's see it in play mode.
All right. Let me just adjust this. And I'm going to hit play. And you hit connect?
Yep.
All right.
Ta-da!
Aww. With this level of artistic quality, Natalie can have really dynamic and expressive emotional performances. And the data is being piped directly in from a phone straight into the Unity editor. All right, are you all warmed up?
Yep, think so.
Do you want to do some recording? All right. OK, so you see over here that we have this big record button, and I'm going to hit record. Yeah, OK. All right, let's see some sad. All right, how about some surprised? All right, now try to throw some shade. All right, now just how about let's end with a big cheesy smile. All right, we got it. And we're done. Cool, go.
All right.
Away.
It's too bad we don't have the rock here. We could get a little eyebrow action in there too, but I can't do it myself. So if we select the animation that we just did, we can actually make sure that we captured it. And it looks like we did. That's great. I can actually bake this animation clip directly from the component. And that's really important because what it allows me to do is retarget the stream or update the character without having to redo my performance, which is super convenient if you have a scene with lots of characters. And I actually have a particular shot that I want this animation to go into. So let's go ahead and turn on Cinemachine. And let's turn on Timeline as well. And you can see this track second from the top here where the animations can go. Get this, all I need to do is drag the clip that I just made directly onto Timeline. And now that performance is part of my cinematic.
Oh, before we do the playback, I recorded a little wink earlier. Can we include that in the playback?
Oh, sure. I see that right here. So for continuity, I'm actually going to blend both of these performances from two different people into one fluid animation.
Tighten up a little bit.
Yeah. There we go. And we'll just scrub through here, get this guy all set up. And let's take it from right about here. We like the surprise face. I heard people laugh at that. All right, here we go.
Oh, my goodness. That's so cute.
All right, how was that?
All right, so ubiquitous sensors. We've got a sensor that can create on-the-fly geometry of our face. We can map that. We can target it to some blend shapes on a 3D model hosted on a server in virtual space. Now our face is perfectly mapped to that thing as long as the camera is pointed at us. You know, seems kind of simple in future world, but you just saw it. And what's even more interesting, I think, there is that they were talking about it for entertainment purposes. You know, so what are ways in which people maybe that are uncomfortable currently communicating with one another could find better comfort? I don't know. The challenge with for good is finding that nice space where you're actually doing good without the repercussions being too awful. And that's what we like to talk about during these meetups. So there's all kinds of places, good and bad, that you could go with that tech. But to see that we're at a place now where this sensor that is on many of our phones can be used to drive a virtual character in near real time is pretty freaking awesome. And the fact that two of them recorded two completely different types of interactions, we're able to combine that into a single character. That also bodes well, I think, for animation and for animated workflows, or for animation workflows. So portable ubiquitous sensors are a path to immersion. 3D animation workflows are changing rapidly, as you can see, not only with volumetric capture, but also with LiDAR and with mocap and retargeting, inverse kinematics models. All kinds of stuff are changing the way 3D animation is going to be done. And the new performance capture interface modalities are starting to appear. So that, if you had told somebody that 10 years ago, I mean, James Cameron would have understood it because that's what he was doing basically on Avatar. But now that anybody can do it, it doesn't cost $1 million setup, you know, to create a volume to do that kind of motion capture. That's amazing. The fact that you could do that in your hand. I'm just waiting for the 16-year-old kid that pops up that's done a Pixar level thing using just an iPhone, right? Anything's possible now. So about these new modalities, as we're talking about new modalities, there's a scene in specific that has always stood out to me as just kind of teetering on kind of the unknown. Iron Man has kind of worked on top of that, and a bunch of different other scenes now kind of modeled similarly to this. They're all speaking the same kind of interaction language. So this is the Nebuchadnezzar coming into dock during Matrix Revolutions. This came out in 2003. This sequence is probably like maybe 5 seconds long. And the person is in virtual space. It's like they're in a version of the Matrix, which is an interface-only version of the Matrix. You can see that all other information has been zeroed out to white. The only thing that they see in their version of the Matrix is the interface to dock this complex machine. What does that look like, right? You can kind of zero out the rest of the world to focus on the job at hand, or you can extrapolate what's happening in the world to create more fun or joy in the work that you're doing. These are questions I think that are going to be popping up. Like, do you change the color of the room? Do you change what's happening in the room? Do you take Alice to Wonderland while she's doing the work in the room? All kinds of interesting things there. So this was brought up in our Discord, and I want to show you the similarities between this from 2003 and this from this year. It gets pretty cool pretty fast. We will need to rethink existing UX paradigms. 3D interfaces will be as large a leap as the original desktop analogy was to the first computer systems. There is a lot of room to explore within these new user interfaces, and we're going to get a lot of stuff wrong. Trust me, like if you're around for the first go, like in the 80s of what computer systems were supposed to look like, there's a lot of garbage in there, and that's okay. It's part of the learning process. Accessibility should be a priority. I'm really glad that Bill brought up the person in the wheelchair. We've had some folks build some systems that are accessible, accessibility minded, and are just incredible innovations in that space. And then the last one, which we didn't talk a whole heck of a lot about because we'll have an expert talk about this at length, is security should be a tenet of the new UX. So guess what? Now that you can actually create these new modalities and record the data that's necessary to drive some of these interfaces, you can kind of understand the way a person moves in three-dimensional space. You could probably, I saw a study that showed some crazy amount of accuracy. It was like 95% accurate out of using gait analysis. Gait is the way you walk. Using gait analysis, they were able to do some machine learning. I'll find you guys the exact study, but they were able to determine with 95% accuracy a single person out of a group of 100 just with some gait analysis done on that single person. We're going to be gathering a lot of data, and if you guys don't like what happened in the last 10 years with that data, we should be very cautious about what we're going to be using the data for and who gets to be the intermediary to process that data. So just keep that in mind. That's a really important one. So we have come now to the conclusion, to the final slide. Things to remember, because there's a lot to remember, and I will share this recording when we're done. Research is multidisciplinary. When we say AR, VR, XR research, we're talking about medical, we're talking about sustainable systems, we're talking about oil and gas, we're talking about ADD research. When we're also talking about this research, we're talking about cross-cutting technologies, sensors, new interfaces, new tech, and it will affect most industries, right? There are very few industries that will go unaffected by this type of research. And the next thing I just wanted to point out, because it's not thought of very often, because we always go, oh, this is the first, this is the first, this is the first. In my mind, I wipe that out. We're building on generations of research at this point. We just kind of happen to be the next beginning, right? The next modality or the next standard, right? We'll see a mouse of the future. We'll see a keyboard of the future. We may not have seen it yet. We may have already seen it, and it just hasn't been standardized. So we're at this next beginning, which, given all the stuff that I just showed, seems to require high portability, ubiquitous sensors, and some form of machine learning. Those things kind of working in cohesion with one another looks to be what is informing the future of XR. And that's me. If you want to reach out, I'm available on Twitter. You can also mail me at dennis@baltutech. I'm all about collaborating. Do you guys have questions? We have an extra 7 minutes here we can burn through.
I want to mention sound too, because audio is pretty important, especially for older people.
Yeah, good point, Bill. Yeah, I realized that I didn't have sound and I didn't have a few others, and I know Peter, being the sound guy, I don't know if he's on right now, but Peter will hit me later that I didn't include sound. So thank you for bringing that up. Definitely, sound is very important, and so is haptic feedback. Those will be meetups that we'll add to the next year of meetups. Any other comments? I do know that some of you, like I said, do some pretty cutting edge research. If you'd like to give a presentation, or if you want to show a few slides or talk a little bit about what it is that you do at a future meetup, we are totally up for that.
One of the, Dennis, thanks for a great presentation. It was really, really good. One of the things that I saw in the hands video, because I'd seen that previously, is they were talking about using that for sign language, almost a text to speech type thing, or speech to sign language output. So, small little benchmark, but a tremendous one for people who have to use sign language.
Yeah, another great point there. I think I don't think we can stress enough how far we can get if we decide to tackle some accessibility tools, right? Like things that just weren't possible before. I love that you brought that up just now. A type of text to speech. If a person could sign and we could see captions underneath that signing, right? Imagine you're wearing a pair of XR glasses or something, and the person's signing, and you're literally seeing the closed captioning below the signing. That all kinds of stuff could be possible there. Don, you were mentioning if they do workshops. Can you talk about that a little bit?
Yeah, I went to a couple like last year where they're just talking about where they've talked about their process in making the hand physics lab and the state of hand tracking and all that sort of thing. They do a bunch of they have paid courses, which I think is why they have the free workshops. But yeah, even those free workshops, it's really nice to just get into their mind and see what they're thinking. And then also they can't do everything that they're thinking, so they're like, hey, we haven't gotten to this, maybe you can. That's really cool. They're really nice.
That's good to know. Thanks, Don. All right, if there aren't any more comments or questions, you get 4 minutes back. As always, we are super appreciative of you joining and contributing and just being part of the community. We're totally down, like I said, to collaborate. Really appreciate you all. So thanks for making the time. I will post this sooner rather than later. I haven't been good about that in the past, but I will be lickety split on this because it's 2021 and we're going to do this thing better. And I'll just send a message out to you all that have signed up for the meetup.